Lesson 2, we're going to look at compare and order rational numbers. So we're going to talk about what rational numbers actually are, and then how do we put them in order and compare them when they don't seem to be in exactly the same form. So our vocab is rational number, common denominator, and least common denominator, and hopefully some of those should be familiar to you. So a rational number is a number that can be expressed as a ratio of two integers written as a fraction in which the denominator is not 0. So what does that mean? All right. Well, look at the Venn diagram below. It shows that the number 2 can be called by many things. All right. So we have lots of different categories we have for numbers. So it is a whole number. It is also an integer, and it is also a rational number, as you can see by that diagram down there. All right. So a rational number is just any number that can be written as a fraction, as long as the denominator is not 0, because the denominator can't be 0 in any fraction. That's impossible. That's why if you try to divide something by 0 in your calculator, it gives you one of those funky messages. All right. So if we look here, it says the number negative 1.4444 repeating. That's only a rational number, though. So it doesn't meet the criteria of a whole number or an integer. So a whole number is just a regular number. Those are like the first numbers you learned when you counted. And then an integer, now we're including our negatives into our whole numbers. And then the rational numbers, as you can see, are all sorts of things. Percents, repeating decimals, terminating decimals, positives, negatives, fractions, all that kind of stuff. So looking at this, let's fill in some of the missing pieces that we have here. So let's start with a whole number. Which number in our number bank is only a whole number? Well, I think number 1. That right there, that's a whole number. That's all it is. How about which one is only an integer? Well, negative 1 is the only one that is a whole negative integer. And that means the rest must be rational numbers, because that's all we have. So we have 0.8 or 8/10. We have 2.2 repeating. And then lastly, we have 1 and 2/3. So most numbers that you're familiar with are rational numbers. The only thing that's not a rational number is a number that would repeat, that doesn't repeat. It goes on and on forever, but it never repeats. There's no pattern. So the classic irrational number, as we call it, would be pi. Pi is one of the numbers we would not be looking at today. So it says not all numbers are rational numbers. The Greek letter pi, just like I said, represents the non-terminating and non-repeating number whose first few digits are 3.14. This number is an irrational number. So it says use the internet to search for the digits of pi. Describe what you find. All right. Well, if you actually do that, you'll find that pi goes on forever. And some of these websites will actually list up to 1 million digits of pi, which is kind of crazy. But there's an actual way to sort of figure out what those numbers are. But for the purposes of this, we're not too worried about that. So compare rational numbers. So a common denominator is a common multiple of the denominators of 2 or more fractions. So that means that if you have 2 fractions, all right, and they have different denominators, a common denominator would be something that they could both get to. So for example, if you had 3 and 5, a common denominator would be 15. 15 is a multiple of 3 and it's a multiple of 5. The least common denominator, or LCD, is the least common multiple of the denominator. So that's the lowest value multiple that they share. You can use the LCD to compare fractions. You can also use a number line. So there's a couple different ways we could go about doing this. All right, so let's look at example 1. We're going to fill in the circle with less than, greater than, or equal to make negative 1 and 5/6 and negative 1 and 1/6 a true statement. So what are we going to put in that circle that's going to make it a true statement? Well, we're going to use a number line for our first example here. All right. So what we're going to do is we're going to create a number line. All right. And since we're looking at 2 mixed numbers that are negative 1 and some amount, we know that this falls in between negative 1 and negative 2. So please note how negative 1 is to the right, because that negative integer is larger than negative 2. And then we're going to fill in all our fractional amounts here. So this would be negative 1 and 1/6, negative 1 and 2/6, negative 1 and 3/6, negative 1 and 4/6, negative 1 and 5/6. Doesn't look like a 5, that looks like 6/6. Let's clean that up. 5/6, and then negative 2, the whole number would be negative 6/6. So there's how the whole thing would look on the number line. And then next thing we're going to do is mark, all right, both of those values. So we're going to mark negative 1 and 1/6, which is right here. And then we're going to mark negative 1 and 5/6, which is right here. And we're going to say which one's bigger. Well, it looks like negative 1 and 1/6 is larger because it's to the right. So we would say negative 1 and 5/6 is less than negative 1 and 1/6. And that would make it a true statement. All right, for this next example, again, we're going to fill in the circle with less than, greater than, or equal to make 7/12 and 8/18 a true sentence. So which one is larger, 7/12 or 8/18? Well, in this example, we're going to find their least common denominators. And really, this works if you use any common denominator. It doesn't necessarily have to be the least one. As long as the denominator is the same, the numerators will tell you which one is larger and which one is smaller. So we've got 7/12 and we've got 8/18. And we need a denominator that is a multiple of 12 and a multiple of 18. So when I say a multiple, that means 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36, and so on and so on and so on. So that 12, 24, 36, a multiple is almost like counting by those numbers. What number multiplied by what number will get you to that multiple? So what is a multiple that 12 and 18 share? Well, they both share actually 36. All right, 12 times 3 is 36, and 18 times 2 is 36. So that's a multiple that they share. All right, so what does that do to the numerator? Well, equivalent fractions, if we multiply the denominator by something, if we multiply that numerator by the same thing, oops, not 12, rather 21. That'll make an equivalent fraction. So 18 times 2 is 36, so 8 times 2 is 16. So now we have two new fractions, and both of them this time have the same denominator. So we can clearly see that since 7/12 is equal to 21/36, and then 8/18 is equal to 16/36, we can see that 21/36 is greater than. So we can put that greater than symbol in right there to make that a true statement. All right, and number 3. All right, we're looking at Mr. Huang's class. 20% of students own roller shoes. I don't know what roller shoes are. I guess they're something like roller skates, maybe. I don't know. In Mrs. Trevino's class, 5 out of 29 students own roller shoes. In which class does a greater fraction of students own roller shoes? So we have one rational number as a percent, and we have one as a fraction. Well, we can't compare percents and fractions just by looking at them. We could turn them both into fractions. We could turn them both into percents if we wanted to. But I'll tell you what, a really easy way to do this is to use the version of these numbers that we're not even looking at, and that's a decimal. So let's find what the decimal form of both these numbers are, and then we can compare them pretty easily, actually. All right. So if we have 20%, let's turn that into a decimal. Well, that's easy. We just find that decimal, move it 2 places to the left. So this is 0.2. All right. So then we have 5 out of 29, as I said, and that's just a division problem. All we have to do is divide that. So if we divide 5 divided by 29, that gives us 0.1724. So which one's bigger? Well, this one's bigger, 0.2. All you have to do is look at that first decimal place. Whichever number's bigger, that's the bigger value. So we know that 20% is greater than 5 out of 29. So that means Mr. Huang's class has a larger number of students with roller shoes. All right, next up is we're going to put these rational numbers in order from smallest to largest in this next example, which is tricky sometimes because, as we said, they don't always have the same appearance. They're not always in the same form. All right, so number 4 here says order the set 3.44, pi, 3.14, and 3.4 repeating from least to greatest. Now, this is kind of a trick because this is a lesson on rational numbers and they included pi in there, which is an irrational number, but we'll roll with it. Doesn't really make sense, but hey, oftentimes life does not. All right, so here we go. We need to figure out which one's the smallest and which one is the largest. All right, so a way to do this is often to line them up by their decimal point. All right, that really makes it easier for us. So let's start with 3.44. Then we had pi, which is 3.141 ... That goes on forever. Then we have 3.14, and then we have 3.444 repeating on forever and ever and ever. Okay, so the problem we have is that they don't all have the same number of decimal places. All right, so what do we do in that situation? How do we know which one's the biggest? Well, the cool thing about decimals is that you can add zeros to the right and it has no impact. So in 3.141, and then 3.444, all right, they extend out further than our 3.14 and our 3.44. So let's just add zeros to each one of those. All right, now that gives us a level playing field. We can look at this. We can even just ignore the threes, and we can determine what's the largest or smallest number here. And if I cover up those threes, as a matter of fact, I'll just erase them all. All right, which is the larger number here? The largest number, or what do we want? The smallest? Yeah, we're starting with the least, so let's start with the smallest number. Well, the smallest number is 140. So 3.14 is your smallest number. What's your next smallest number? Well, it looks like 141, so that means 3.141, which actually, as we said earlier, that number is pi. So that's your next smallest number, all right? So then the next one, all right, would be 440, so 3.44, and then that leaves our last one, 3.4, repeating as our largest value. So the interesting thing is that even though 3.44 terminates at the second 4, it's larger than pi, which extends forever, because all those decimal places further out are so much smaller than that 4 100ths there that it makes it a smaller value. All right, last example. It says Nolan's the quarterback of the football team. He completed 67% of his passes in the first game. He completed 64 hundredths, 3/5, and 69% of his passes in the next 3 games. List Nolan's completed passing numbers from least to greatest. So they got a pretty wacky stat collector here who seems to do things rather erratically. So you got a few percents, you got a decimal, you got a fraction in there. We want to see which one is the smallest and which one is the greatest. Well, again, just put them all in the same format. And to be honest with you, the decimal format is the easiest one to get to and the quickest one to make comparisons. So start with 67%. That, just move that decimal 2 spots over. So we got 0.67. All right. Then we've got 0.64. Well, we don't have to do anything there. That one's still 0.64. Okay. How about 3/5? Well, that's just 3 divided by 5, which is 0.6. And then our last one we said is 69%. Again, just move that decimal over 2 spots. 1, 2. That becomes 0.69. So I'm going to throw a 0 here after that. Instead of 6/10, I'm going to make it 60 hundredths. It's the same thing. Remember, I can add those zeros. And now I can just compare. Which one's the smallest? Well, 0.60 is the smallest. 60 is the smallest. So the smallest would be 0.60. All right, which we said is actually 3/5. All right, our next smallest looks like it is 0.64. Our next smallest was 0.67, which we said was 67%. And that leaves us with 69% being the largest amount. So there are his completions from smallest to largest. All right, so you guys have some guided practice for tonight. You have 1, 2, 3, 4, 5 problems. Get those done. We'll talk about them tomorrow.